Okay. And next, parallelly, we have a right turn. So once if the vehicle is right turn, we need to understand whether right turn is happened or not. This is one state. And warning light, if nothing is happening, means whenever you make your vehicle to turn left or right, there will be the indicator, right? So this will give that it is happening in the left or the right kind of thing. And next will be the so the data, that whatever the data we need to transfer, so it carries the message and headers. Okay, that is what we discussed about the frame format in the previous sections. So the LDF file is the LIN description file, the full form of this. Okay, it contains all the individual nodes and messages and signals. So it have all the messages and signals in detail, and how these messages and signals will be transferred uh, in the devices. It will be with the help of the frame format. Okay, so the master header means the here the message will this will be the part of a master, and here it will be a part of a slave. So the master, it carries the header info message header information. It have the break, sync, and identifier, and the slave address, it will be there. So the slave response means here it will be the request where it will be a part of a request master will do, and this will be a part of a response, the slave response. Okay, and it have the data. So the data, what exactly the messages that we are sending, like we saw turn left, turn right will be there, right? So that we need to send the data, and whatever the data we are sending is correct or not, so that will be checked in the checksum. Okay, so we need to understand the fields of the this is a complete frame. So in the frame, it have the break, sync, and identifier. It comes under a header. Okay, and coming to the response, the data will be there and checksum will be there. So this is the points you need to remember. So the header contains the break, sync, and identifier, and the response, it contains the data and checksum. So these are the 5 points you need to remember. In interview, what is the frame, the LIN contents, you need to give this info. Okay. So remaining, like if they ask you in between header and response, what will be there? You need to give that response space will be there. So once after that, other frame, what it will be there. So you need to say that inter frame space also will be there in the frame. So this is add-on points we need to give, but the first 5 points, whatever I highlighted, these are very essential. You need to give in clearly, and we'll discuss in detail about each frame in the LIN protocol. Okay, so this is a frame we need to consider the header and the response. So LIN frame, it is the fundamental of the unit for data exchange, means whatever the master and slave, that should be transferred the data. Okay, so it should have followed this frame format, and moreover it contains the header and response. With that only the master and slave eh, exchange the informations. Okay, so that is what the transmitting and receiving of the information can happen from master to slave. And what are the sync break? So it is a sign of the slave that transmission will follow. Okay, so the sync break will be there. So and next we'll have a sync field. So this is about the synchronization. Okay, so uh, it will say that whatever the slave we need to adjust, it will give the speed of the own speed, like what is the speed you are transferring. So that is a kind of a baud rate. And next we have an identifier. So as I told you, with respect to the ID, from the master to the slave, data will be transferred, like data 1, ID 1, ID 2. So the data based upon the slave uh, identifier, the data will be transferred from master to slave. And next we have the data field. So data field is we are able to transfer 0 to 8 bytes of data at a time. And checksum, it is used for error correction, like whether we are checking the valid message or invalid message or not, so that we are checking it in the checksum. So this is a just overview you need to give in interview. Okay. So is it clear? So you need to highlight this sign for the slave that transmission will be followed. So it is for indication of the slave that uh, we are able to transfer the message. And we have this sync. It will be the syncing of the information. Just it is adjusting like whether I can transfer the data now or not. So it will be a part of the sync. Okay. So is it clear? So this is a complete frame format. Okay, in interview, we need to give only the overview. Okay. So to know in detail information about what is the break, what is sync, and what is identifier and what is data, yeah, we can go with this format. So usually the message frame format, it will have the header and response. It have the sync break field and like the previous concepts we discussed, break, sync, and identifier. So the header have this information. Whatever the break, it will be there, right? So it have the information about 13 bits. And next to the sync field, the frame which we are transferring, it should have the ID. And next we have the frame of data that we are sending is correct or not. Okay, so sync is synchronized break and del is the delimiter. So about this frame, whatever the del here mentioned, and PID is the protected identifiers and the PID. So next is the serial communication interfaces. So LIN message is a specific structure. It have the header and response. So first the data, like whatever the token, no. So from the master to slave, the master will say that okay, master should send a token first. Okay, whether it should take a permission. Okay, so then then only the master can send the data from master to slave. So for requesting the token, it will follow the sync and so the break and field and the PID. So PID is a protected identifier, means the ID. Okay, so it will be the we call as a the protected ID means it's specific to the slave we are sending the data. So that is in detail information. Whenever interview you need to say that identifier only. Okay, so that is the ID you need to say in the interview. This is for for your information. Whenever you are referring the documents in the real time when you are working, they will mention like PID. So for that purpose, I mentioned the protected identifier the in the bracket PID. Okay, so this will be the sync break and sync fields will be there. So this will be requested by the master to send the data. And what this sync break and sync fields are used? Okay, so it is the responder for the LIN bus for synchronization purpose. Okay, so that will be considered as the whether the message will be sending or not. And PID, so PID is the identifier. So what it will be contains, so which who to respond and whom I need to send the data, whom to be the data will be sent successfully. So that all will be considered under the part of the identifier. And next will be the header. So it generally it have a count of 13 bits. That is the sync brick. Okay, so sometimes in interviews they will ask you. Sometimes when you are working in the real time, you need to see how many bits will be there in the sync field. So that will be the 13 bits. And next we have a delimiter. So delimiter in the programming, it will be the end of the section, right? Similarly, here also we are following the delimiter 1 or 0. Okay, so 1 or 0 is it will end up the frame. Whatever the break is there, the break should end up with the delimiter. And next we have the 10 sync bits field. So whatever this sync field will be there, it will be in 10 bits. So one will be the start bit and 8 bits will be the for synchronization and 1 bit will be the start bit. And next will be the 10 identifier bits. So that identifier it have the information of one start bit, 6 bits of identifier, and 2 bits for parity, and one stop bit. So this is a general overview about the header. Like who needs work on the programming, they need to know about this data. Okay, so how many bits or fields will be there in each container. So like a header, we'll discuss on the header. So header, it contains the message information. So it have the unique ID identifier. Okay, so on frame type, so the frame type is the type of the message that we are transmitting. So the which protocol or which communication, which slave that will be selected as a frame type. And checksum is used for error correction. So this will be a part of the header information, means whatever the message request that we are sending, right? So that message request will be comes under a part of the header. So as I told you, right, like in the frame we have the header and uh, the response. So the header information, it have the identifier specific should go, and the frame, which frame I need to send, and whether the sending data will be uh, errors will be captured or not. It comes under a part of a checksum. And next will be the data. So whatever the data that we are transferring, so within the header and response. So in the response, we have a 8 bytes. So maximum in the LIN protocol, we can send 8 bytes of data. So that 8 bytes will be comes under a part of the response frame. So it it will checksum will consider that whom should data should be received or not. Okay, and response. So response is the actual data that we are getting it, and so it have the control signals, sensor readings, and commands. Okay, and this is the purpose of the LIN protocol. Like whatever we are reading the data, so that it will be related to the control signals and sensors related and commands. Whatever the input we are giving, right? So that will be parts of the commands. So this all related messages signals we'll read in the LIN protocol. So what are the advantages of the LIN protocol? So LIN is a single wire based interface. So where the cost will be very less and it is easy to implement. And it is a self-synchronized. So we don't want any clock because it is a asynchronous protocol. The clock is not required. And it is a best and most suited alternate, like compared to the some of the other protocols like CAN, Ethernet, or FlexRay. So this LIN is the best for using in the low speed applications, and it have the high bandwidth and low speed applications. And what is the disadvantages of the LIN protocol is, so it is a low speed, okay, and for safety concerns it's not sufficient because like you need to you have a airbag and you have a engine, and meanwhile you car going in some speed, the airbag it should open within because when it will collide with any other like if it is the hill or any car will be there, so that time it should open the airbags within milliseconds of time, because the passengers or the drivers in the car should save within the 1 millisecond or 1 microsecond level. Okay, so that much safety concerns should be required for the faster communication. So, but LIN, it is slow, and its speed is will be 19 kbps, and it will react very slowly. Like it will be like a 2 seconds or 1 second, 3 seconds of time. It will react means the passengers will die, then airbag will open. That is no safety in that case, right? So here this whenever we are using this LIN protocol like the windows or sunroof, all those applications, it will be very easier uh, for some of the applications. It won't be not applicable. That is a very disadvantage of this LIN. And here and as I told you in the previous classes, always the master only will send the data. If I fix that master, okay, master, you only need to send the data all the time. So the master only fixed. It is not a multi-mastering. Means whoever send the data, he should act like a master. No, the master is the one. He only need to send the data all the time for the slaves. So that is a one disadvantage of the LIN protocol. And next will be the part of the error checking. So because whatever the data that we are transferring, right, so it will be 8 bytes of data. So here in the LIN protocol, the checking of the 8 bytes of data and more than 8 bytes of data, it will be very tough, right? So that is a one difficult phase, like only allowed only 8 bytes of data. So there is no strong error checking mechanism in the LIN. Means if I send more than that, it won't work. Means the communication it will last. It will if I send 9 or 10, it will consider only 8 bytes. So that is a very difficult, right? So that is a one reason it it is not strong in the error checking. So generally, when we monitor in the scope, like we know about oscillator, right? Oscilloscope. Oscilloscope is specifically to monitor the electric signals. Okay, monitoring the electric signals. What is electrical signals? It's related to the voltage or current will be comes under a part of the electric signal. Whatever you are saying, right? It is the voltage. So the voltage will be there. So it will be what is the voltage? It starts from 0 to 3 or 5 volts, and this will be the time. So what will be the voltage? It have the duration for this extent, and what will be the short duration it happened. So this all will be part of the oscilloscope where we can monitor the data. So from here, within the oscilloscope, we can see we have the header and message response. So that can be, this is a frame, like whatever the header will be selected and response will be the data that is transferring. Okay, this is oscilloscope. With the help of this, we need to monitor the data, how we are sending in the real time. Okay, with respect to the signals you need to see, or the frame you need to see signal values. Okay, signals is like whatever we saw, the left turn or right turn, that will be the signals. So how it is acting is whatever the voltage that we are uh, giving from the controller, means from the ECU controller we say, so that signals will update. Similarly here we are able to uh, transferring the from master to slave, how that voltage is happening, how these ones and zeros are coming. So it will whenever it is rising means it will be 1, when it is falling is 0, 1, 0. So the duration of the this time, it means imagine like this is a 1 second, it have 1, and this will be like a 0.2 seconds, it have 0. Again it started 1 second for the day, it will be in a 1. So like that the data will be transferred within the scope. We can understand what will be the data and it is happening. And the important concept is the default value will be 0xC3, and the response ID is 3D. And we cannot send more than 8 bytes of data. That is one disadvantage in the LIN protocol, so that we discussed. And what is a mode of LIN? Means the mode of LIN is we have the 3 points. So whenever the controller is not working, imagine like this is a controller, okay, and we'll go with the whatever we previously discussed with one of the example. So here I have a sensor. So the sensor of door. So that sensor of the door will be there. So what it will do, whenever the person goes near, so it have the radiation, right? So it has some frequency, it is covering the region. Okay, so whenever the person enters, at that time the signal will send the data to the controller. This is my is controller, means I called as a ECU. Okay, so this ECU, what it will do, it will this is the input. Now my output will be the motor. So the motor will start here, this my motor, it will open the door. Means during that time, if there is no person, what my controller is doing, what my ECU is doing, So it is in a sleep mode or working mode. How we can know that? Okay, in this is very essential. Like whenever it something is not communicating, that time the controllers will be in a sleep mode. So whenever they need to send the data, that time the it will start communicating and it is working efficiently. Means that time it won't utilize the power, the current. Okay, so whatever the power supply will be there, but whenever the sensor is working, motor is working, that time the current draw will be there. Means it required some power, right, to rotate the motor or to sense the information. It required some data to push or send, right? So that time only it should work. Okay, during that time it will be in a sleep mode. So like what is a sleep mode? Sleep mode is the node, means whatever the ECU we can say. Okay, because in the network we are discussing, right, it is in a low power state and it consumes only less energy. So this is the first point you need to remember and you need to write it. And sleep mode is typically used when node is ideal or inactive and there is no immediate needed for the communication. So these are the 2 points you need to write it and you need to remember. Okay, when in the sleep state, the node doesn't actively participate in the LIN network and remaining, it will be in a low power standby state. Means it won't utilize the energy and moreover, the power consumption will be very less during the power mode, sorry, sleep mode. And sleep mode, it allows only power saving benefits and that too, especially in the cars. Okay, because when whatever the cars we are using, right, we'll use for lightening lights, we'll use for entertainment of the songs, and moreover the like supplying of the charges. All this required energy, right? Somewhere some power should be generated. When it will be generating, so we need to charge the battery every time, or we need to gives additional energy from the fuel, that is not good, right? So supplying additionally, because some of the vehicles are coming up with the more braking system. During the braking the vehicles will be charged, and sometimes we need to additionally charge the batteries, and sometimes we need to um, supply the uh, power from the charging point. Means if you say during the engine is started, once the engine is started, it will whatever the power until the engine runs, the light will glow or the songs can play. If it is stop, it completely stop. Means that is a initial phase of the cars that we have nowadays. Whatever the cars we are getting, so it will be charging during the runtime only. So sleep mode allows for power saving benefits, especially in the automotive application where energy efficiency is essential. And nodes means whatever the controllers that will woke up from sleep mode by specific events. Okay, so how we need to, when something is sleeping, we need to woke up, right? So that we call as a wake up signal. So how that we are sending in the LIN bus. Okay, so with the help of LIN bus we'll send it in the control, like it is like some example, like as we discussed. Similarly, we have a window in the cars. So whenever we press the button of the switch, okay, so in the car the window will be opened. So that until after that time, the the whatever you pressed, we are not giving any input. So the input cannot go to the ECU, and even the ECU cannot send the information to the doors. So like that, it completely stops. So and like whenever you press, so means that press will be the part of a wake up. So we are waking up the ECU, and then only the window will be open. Means the output will be acted. So that's how the wake up will be considered. So this is a sleep mode. And next we have a concept of wake up, how the wake up will work. Okay, so meantime we'll discuss about the normal mode. Means whatever the controller is working, right? So that we call as a normal mode. Means the persons are coming continuously and it is opening the door and closing parallelly, and even the real-time scenarios, it's reading the information continuously and it is updating us. It will be considered as a part of a normal mode. Normal mode is the primary mode of the operation for the LIN. Okay, during LIN regular communication. It is not only for LIN protocol, but for all the like CAN, UART, FlexRay, all the protocols have the same feature. But initial phase of understanding of the LIN, so we are discussing about these modes like sleep mode or normal mode will be there. And moreover, this in normal mode where we can transfer the data and receive the data where with the help of the messages. So some messages it have the scheduling when you need to activate, when you should not activate, like that scheduling will be there. And each and every message it have the master or slave should be communicated. Okay, so as we know, master will initiate the message for transferring of the data, and slave should be receive the data with respective data whatever it required. And some of the it allows the event trigger communication. Event trigger communication is whenever you are pressing the button or sensor is reading the data, so this will be a part of a event trigger communication. In this normal mode, this is a very important statement you need to consider. And other part will be this is the second point you need to consider. And these are whatever I highlighted, these are the points you need to write down in the notes and for understanding this what is a normal mode working. And the main thing is event trigger. Event trigger is whenever we hear some disturbance is creating, right, that will be part of a event. Okay, so that event trigger is very important keyword. And next is a woke up mode. Woke up mode is like as we know, whenever the sleep mode is, it will be there. And from the sleep mode to we need to wake up to normal mode. Okay, so that we consider as a wake up mode. Okay, so from sleep to normal mode, we know about normal mode. Mode is it where the exchange of information is happening, where data will be transferred in the wake up mode. And like a wake up is signal is detected on the LIN bus. Okay, wherever whenever you power on, okay, and you have a normal communication, so that time the wake up will be happening. So these are very important 2 points you need to know about what is a wake up mode. In interviews they will ask you, you know about a normal mode or wake up mode or sleep mode and all. So, and sometimes they will ask you in sleep mode whether the data communication is happening or not. So no, you need to say. And whenever in you do in normal uh, mode, so what will be, whether the communication is happening or not, you need to say yes. And during the wake up mode, how the message will be sended from sleep mode to normal mode or normal mode to sleep mode. So like that, they will ask you the cross questions on this. You need to clear on this concept. This is a one real time concepts keywords that I am saying. You need to understand this. Okay, so wake up mode is what is the specific purpose of wake up mode is it is like transition. So from low power state to the active state. Okay, so that will be considered as a wake up. And in real time applications, our this LIN protocol we are using in the cars. Okay, so the example of is like we related to the roof, sunroof. So and moreover we apart from the sunroof we have the glasses. So it's the rain sensor should be detected or light sensors or ambient lighting. So that these are the additional features towards the roof. Okay, because only closing and opening is not considered, and it have the rain detection because you have a sunroof and the transparent will be there. Okay, so when you it is opened due to the glass, some cars they have the glass for transfer sunroof, and some they will close fully with the metal. Okay, so whenever you are closing the sunroof, so it have both features. The glass feature will be there and the metal feature will be there. So whenever you require the metal, you you don't want sunroof, you can close with the metal. You need lightning in the car, so that time you can remove the metallic and you have a glass. So you don't want glass also, so you can remove the glass. But the glass have some features. So because some of the high-end cars, it requires the sensors, that is a rain sensors. Whenever some raindrops are falling, right, during the lightning, it should sense. And moreover, water should not fill, right, so it should clean away. So there are some features. Whenever rain is dropping on the car, this glass, the water should be go away, some pipeline. So that features all will be part of the cars, that high-end cars can be implemented. Okay, and next application will be the seat. So because when you are sitting in the car, on the seat, it will be heated up. Okay, so the back end, you will get a back punch, and you cannot sit for a long time on the safety or luxury cars. So what they will do, in the seat only, they are making the cooling fans. So whenever you sit on that chair, right, so you will feel that you are a weightless, means it feel very luxurious and comfort for sitting. So that is a one very important application project. So it where the luxurious came into the seat also. Okay, for this communication we are using. And for the climate control, like you need to control uh, internal application. When you are sitting in the car, you need to adjust the lighting, or you need to adjust the fan, like a cooling system, like a temperature of your car, like a heat or climate or a cool climate. Make if some you need a heat, means when you are sitting in the car outside, there is a very cold. When you sit in the car, it needs you need some heat. So that time you need to adjust the climate. So that kind of controlling activities we can make it on the LIN communication protocol. And next will be the steering wheel. So even the steering wheels have this LIN communication protocol, means so the wiper system and airbags, some of the airbags and orange. So this all single wire line communication protocol. And coming to the doors, so doors will be also considered as a part of the uh, LIN system communication. Means in the car, so with all these modules, we are communicating with the LIN protocol. Okay, so like we'll understand one real-time concept. So like we know that in the canopy, like whatever the messages signals will be there, we are able to see the information. The message means first whenever you are requesting this, so that time the sleep, it will wake up. So once it is wake up, the message will start sending. Okay, so this is for just info. I will show in the real time, like in the Canoe, how this message will be transferred. So, like whenever you are communicating with the sunroof or mirror or the wiper system, so here for that, all the sensors, you need one master. So this will be the master. Remaining all will be the green ones, will be the slaves. And just gateway is the communication. This is the other models where the communication is required. Okay, so like example, if you say this is a different protocol, you have a UART, you can also have a CAN, you can also have a FlexRay. But to communicate, this is a model from with the help of the gateway you are communicating it. But here is our actual LIN protocol, means it have the single LIN communication. It will be the master, and remaining will be the slave 1, slave 2, slave 3, and slave 4. So based upon the slave, the data will be read and transmitting will be happening. So in LIN component, each sensor or actuator, so where we are able to transmit and receive the LIN messages. Okay, so how the sensors we are connecting. So let's take one example. This is our controller, means the ECU. In the cars, it will be okay. So electronic control unit. Okay, so this is the wiper motor. Wiper motor. Usually cars have the front, right? So it have this system. where it clear the line under, right? So for that, the back end, we have the motor. The bottom, you have the motor. So this is the motor. So what it will do, it will start rotating the clockwise and anti-clockwise. So that's how it will be. But how this controller is connected to this motor? So here we have a LIN wire. So the LIN wire is connected. This is the feedback. So this we call as a feedback. Feedback means whatever the signal exchange will be happening with respect to the TX and RX. And we have the power supply, the other pin, and next will be the ground. So these are the three pins that we are giving to the motor. So like I have a motor. So for that motor, the power supply and the ground, GND I will write, and this is the feedback. So this I am connecting to the ECU. Okay, so here this is a my master and here is the slave. So how now whatever the data we are sending, it will be transferring in the header and the response. So the data we are transferring in the frames. Is it clear still now? You are able to understand in how the physically like we are connecting the controller and the motor. I need response from you all. I given you the wake up. Now I am wake upping you. You need to wake up from sleep state to wake up mode. At least normal mode. You need to come to normal mode now. Okay. So all are wake up. I need response that you are a normal.
Yes, sir.
Yes.
Yes.
Okay, good. Who are sleeping still now?
Yes, sir.
If you are sleeping, wake up. I given you some signal to you. You need to wake up now. Okay. Did you wake up? Still? Okay. If someone not responding, then that person should wake up more. We need more signal to send to them. Then only he can wake up. Might be.
More
Okay.
voltage.
Higher voltage. Yeah, higher voltage and like 480 volts. How much voltage we need to supply then? Everything will blast. Even the
But
equipments and
480
all
volts it will blast.
will blast high voltage then.
Three phase voltage we can give.
Base voltage. Okay. So that much is required to wake up. Okay, good. So hope that is better. Like someone can actively responding is required. And this is a wire, like how we are communicating with the wire. Even interviews, if they ask you like how we have the ECU and how you are connecting the motor. So what are the pins it have? Like you need to explain. Like we have the power supply and the ground and the LIN wire. Just understanding of the LIN protocol in real time, how we are connecting. I'm explaining this, guys. Okay, so it is not a project for you. Still, we have to learn more to work to understand the project. Okay. So in the this is a one project only. Okay, this is Viper system is a one big project. Okay, so most of the peoples can work for 5 years, 6 years, and even 10 years. They will work for the project continuously. Viper system only. Apart from that Viper system, they don't know any other models. So like that they will work because what is there? You think about okay, what is there? There is only motor and signal and ground. Yes, there is a link communication, right? So whatever the data you are sending to the motor, it is happening or not, and whatever the failures are happening, whatever the safety features they are implementing in the software, all those will be coming into a part of the communication. Okay, so that is a very essential. Whatever the development side, hardware side, or software side, so they're continuously they are doing the testing activities. Okay, this is a one real-time project like we usually work. Okay, so and coming to the messages, just for our understanding, how this device will be sending the information to the motor and how this motor will sending this data to the master. So usually we have the sync break. So whenever the sync break is the first ID information, it will be the first part. Okay, and previously we discussed about delimiter. It is the end of the break. And we have the next, the sync, break, sync, and identifier. So identifier will be there. So next is whatever the data we are sending, it will be sending like this is like electrical signals. Okay, so we can, as I told you, in the oscilloscope, we can see this information, how the messages are transmitting. And wherever you are seeing the peaks, right, like the high peaks, so this will be the ones and the low bottoms will be the zeros. So like that, the data we are transmitting. So it won't requires the clock. Okay, so that is just the message structure, just we summarized. And coming to this voltage level, as we discussed, wherever it is rising, it will be the ones, and fallings will be the zero with respect to the voltage, and the timing only the data will be transferred. Okay, so this is other important point, and they, some normally it will be the slew rate. We usually say what is slew rate. So what is the rising time and what will be the falling time. We consider as a slew rate. This is for just subject only to understand. So whenever you are, this is for our understanding. Okay, in real time we need to think like this. Okay, it is falling and rising. Generally, whenever it is happening, right, there will be a slight deviation. Okay, so the signals, it won't be in a straight. Instead of this straight, like imagine like it is a falling high and zero. Okay, it will be like we are understanding in the real time, like okay, the data is transferring 1 to 0. Actually, it won't be like this. It will be transferring like this. Because slow falling will be there. It won't be immediate falling. It will be the slow falling in the current, because as we know about capacitor, so capacitor, what it will do, it will charge and discharge. Charging will be there when you are giving the power, and discharging will be there when you are removing the power slowly. Like as I told you, some of the plug points or the TVs, whatever we are seeing in the homes, right? So whenever you make power on or power off, whatever the LED will be there, that LED will be slowly, it will go off and come off slowly. So similarly, whenever you are making the transaction within the devices, it have the small capacitors. So what it will do, it will make the transaction slowly discharge. From charging to discharging will be happen. And whenever I need to rise it again, it will rise the peaks again. So this will be a part of a slew rate. What is the so who are studied engineering, they know about this slew rate and all. So what is the time, rise time and release time will be there. So this will be the part of the released rise time, because it is rising, and release time is the falling one. Okay, so just for knowledge, I am explaining. In real time, we won't use these keywords, but as a part of knowledge, we need to know how these electronics are playing very major role when they are making a transaction from 1 to 0 or 0 to 1. Okay, is it clear? So in real time, when we speak, what is a one? We should not mention one. Okay, so when towards the protocol. So whenever it will be there, one means it will be a recessive. Whenever it will be a zero means it is a dominant bits. So these are very important points you need to remember. So whatever the one you are able to see in the screen, right? So the 80% of the percent will be the 80% will be the battery voltage, that will be a recessive bits, and dominance 0 bits will be a 20 bits. Okay, so 1, so 0, 1, 0. Okay, because whatever it occupied, right, it the space it occupied 80%, just for example I am saying. And here whatever the remaining space, it will be only 20%, means whatever rising and falling, it will take some data information, means it taken some space, that will be 20%, remaining it will be a whatever the space it occupied, it will be the 80%, and remaining it will be the 20% space. So just for your understanding, how the voltage transactions will be happening with respect to the protocol, means as I told you, like whatever the data you are transferring from the protocols, it always ones and zeros only, but it will be formed in the form of frames. Okay, so the message frames will contains this information, and it will be transferring the data. Okay, is it clear still now? Similarly, this is for one more example. So we have the battery. The main battery will be there, like in our bikes or the cars. So we have a battery inside the vehicle. So whenever we need to charge or discharge, so means if something it is key is not, the bike is not working or car is not working, when I make a turn on the key, means the battery is no volt. It won't have any energy, any power in it, so that will be drained up. So whenever you turn on the key, this is a ignition key. Okay, so this is your bike key, this is your car key, anything that you can consider. So what this key, you have two inputs. So the one input is given to the battery, and other one you given to the motor. Okay, so whatever the battery, when you turn on this, so it will go to the controller. So here I have my controller. So what this controller will do, this controller will send the signal to the uh, motor. So this is my motor. Okay, so the motor will be started, and meanwhile the battery will be there. So the battery, it will take the charging, means because to start the motor, it required the it required some power, right? So that will be taken from the battery, and controller is the green one is the signal where the information is we are giving it. So just for understanding on the brief, like when you turn on something to start, because I didn't add any engine here to make sure that whenever you turn on key, how the bike is started or how the car is started. So just to inform you that how the motor will work. So as I mentioned, it is a vehicle charging system. So similarly, like this is a one future. Usually it have the alternator. So it will convert the mechanical energy into the electrical energy. So what because to charge the battery, similar way the connections will be giving here. So here I mentioned some of the information, you can go through it to understand. So here you have a D plus. What is a D plus is the so in alternator we have this. It is a charge warning light circuit to rotate the field winding, and you have a W. It is for speed detection purpose, and you have a B plus. It is for the battery lit. So just you can go through it to know the connectivity of the system. So like summarize of this LIN protocol. So we are able to connect with slaves of 16 slaves, one master. Okay, so master is the one, the main head of the unit, and the slaves are the one who able to receive the information. And it is a linear bus topology. We have a single wire for communication, and the whatever the data that we are transferring, it will be transferred in the form of message data packets. So this is about understanding of the network topology towards the LIN, and some of the properties like we discussed. So these are very important. It have the low cost, and where we are using in the Windows and Viper system and air conditioning. These are Windows is a one project, okay, and even Viper is also one project, and air conditioning also. These are very very big projects, okay. In real time, we usually work for the 3 years, 4 years, 5 years. We'll work for continuously, and it is a one master 16 slave communication, and we are able to operate up to 40 meters, and moreover, it will be the time triggering scheduling. So once you send the message, definitely the data will go to the slave. It won't wait. Okay, so it won't stop also. That will be the guarantee latency, and we can transfer to 8 bytes of data.